This is 11.2, operations with radical expressions. Like radicals have the same radicand. For example, if you had 5 square roots of 2 and negative 3 square roots of 2, they have the same radicand, the square root of 2 and the square root of 2, so they would be like radicals. Remember, we can only add and subtract like expressions, so you could add these together. Unlike radicals, do not have the same radicand. For example, you could have something like the square root of 11 or 2 square roots of 11 and 3 square roots of 7. Those are unlike radicals. The square root of 11, they do not have the same radicand. Square root of 11, square root of 7, those are not the same radicands. So in this example, or in this lesson, we're going to be simplifying radical expressions. So remember, you can only add like expressions. We cannot add unlike terms. So in example 1, we're combining like radicals. Notice these square root of 3 and square root of 3, those are like radicals, or like radicands, therefore you can add them together. Remember to treat your radical expressions like they were x's. If they're the same thing, for instance, instead of 4 square roots of 3 plus the square root of 3, we could say it's just like 4x plus x. If we were adding 4x plus x, I have 4 x's plus another x, I have total 5 x's. That's the same thing you do with your radicals. I have 4 square roots of 3 plus another square root of 3, so I have a total of 5 square roots of 3. And that's your answer. Okay, let's look at these. Negative 3 square roots of 5 minus 4 square roots of 5. So again, they do have like radicands, so we know that we can add them together. And if you want, since you know these are like radicands, you can go ahead and say it'd be the same as doing negative 3x minus 4x. So what would we do there? We'd say subtraction is the same as adding the opposite. Negative 3x plus negative 4x, that's negative 7 instead of x, square roots of 5. Negative 3 square roots of 5 minus 4 square roots of 5, I have a total of negative 7 square roots of 5. Same thing on B. I have the square root of 10 minus 5 square roots of 10. So that would be like doing x minus 5 square roots, the square root of x minus 5 square roots of x. What am I doing? Okay, oops. Didn't mean to do that. Let me undo that. Okay, let's try this again. We want to get rid of the square root. So we have x minus 5x, right? It's the same thing. So if I have x minus 5x is the same as doing x plus a negative 5x, that would give us negative 4x. So here, same thing. If I'm doing the square root of 10 minus 5 square root of 10, it's the same thing. You can put that little imaginary 1 there. 1 minus 5, that's negative 4 square roots of 10. So remember, just subtract your numbers, add or subtract your numbers, and then tack on that square root of 10, or that radicand. Simplifying to combine like radicals. So if we look at this, 8 square roots of 5 minus the square root of 45, these are not like radicals. And the square root of 5 I can't do anything about, but when I look at the square root of 45, I notice this is kind of a big number. I can probably do something about that square root of 45. Maybe I can simplify it somehow so that I can end up with like radicals so that I can simplify these two terms together. So that's what I'm going to do. I'm going to leave 8 square roots of 5 alone, minus, now I'm going to simplify the square root of 45. And I know 45 is 9 times 5. 9 is a perfect square, so I'm going to leave it alone, times 5. And then I can simplify that. So the 8 square roots of 5 minus, what is the square root of 9? 3. So I pull out the 3, and 5 has to stay inside, 3 square roots of 5. Now, since we simplified the square root of 45, notice that now we do have like radicands, and we can do 8 square roots of 5 minus 3 square roots of 5. So again, just think of it like 8x minus 3x, which would give you 5x. So 8 minus 3 is 5 square roots of 5, and that's your answer. Okay, let's look at a couple more of those. The same thing. The square root of 20 and the square root of 5, those are not like radicands. But since 20 is kind of a big number, I'm thinking I can probably simplify that to end up with like radicands. So that's what I'm going to do. I'm going to simplify the square root of 20. So I have 3 square roots of 20 would be 4 times 5, and 4 is a perfect square. So I'm going to leave it like that, plus 2 square roots of 5. And then we simplify. 3, the square root of 4 is 2, so 3 times 2, square roots of 5 has to stay inside, plus 2 square roots of 5. And then 3 times 2 is 6, square roots of 5, plus 2 square roots of 5 equals 6 plus 2 is 8, so 8 square roots of 5. Again, remember, you can only add them if they have like radicals. So 6 square roots of 5 plus 2 square roots of 5 would be 8 square roots of 5. And again, at B, same thing. So the square root of 3, which I can't simplify, but the square root of 27, I can definitely do something about. I want to try and turn these into like radicands so that I can add or subtract, combine like terms, basically. So I have 3 square roots of 3 that I'm not doing anything with, minus 2 times 27 would be 9 times 3, and 9 is a perfect square, so I can take the square root of it. So I have 3 square roots of 3 minus 2 times the square root of 9 is 3 square roots of 3. And that is 3 square roots of 3 minus 2 times 3 is 6 square roots of 3. So what's 3 square roots of 3 minus 6 square roots of 3? Again, remember, it's just like doing 3x minus 6x. So subtraction is the same as adding the opposite. So negative 6 and positive 3 would be a negative 3x, so negative 3 square roots of 3. 3 minus 6, negative 3 square roots of 3. All right, example 3, using the distributive property. So we're still just trying to simplify radical expressions, but in this case we have to distribute the square root of 5 to both these terms inside. So again, I'll simply distribute. The square root of 5 times the square root of 8 is the square root of 40. Then the square root of 5 times 9 is simply 9 square roots of 5. Just like when you would multiply, if this were an x out here, x times 9, 9x. The square root of 5 times 9, 9 square roots of 5. So all you can do with these is just kind of smush them together since they're not the same. The square root of 5 and 9 are not like terms, so when you multiply them, you squish them together. Okay, but we want to see, can I simplify this any further? The square root of 40 is still kind of a big number, so is there anything I can do with that? Well, the square root of 40 would be the same as 4 times 10 plus 9 square roots of 5. And so that I could simplify to be the square root of 4 is 2 square roots of 10 plus 9 square roots of 5. Now, can I add these together? Well, unfortunately you can't, because the square root of 10 and the square root of 5 are not like radicands. This would be like me trying to add 2y plus 9x. They're not like terms. The square root of 10 and the square root of 5 are not the same, and you can't simplify the square root of 10 because it's just 2 times 5. You can't take the square root of 2, you can't take the square root of 5, so there's nothing else you can do. Therefore, it's in simplest form, you have simplified, and you are finished. All right, let's look at a couple more examples of that same thing. So again, you just want to distribute first. We're trying to put it in simplest form, so distribute first. The square root of 5 times 2, 2 square roots of 5. We always want to put our radical in the end, number first. Just like if it was x times 2, it's 2x. Square root of 5 times 2, 2 square roots of 5. And the square root of 5 times the square root of 10 is plus the square root of 50. Well, since 50 is a big number, I know that I can probably simplify that. So I have 2 square roots of 5 plus 50 would be the square root of 25 times 2. 25 times 2 is 50, and 25 is a perfect square. So I have 2 square roots of 5 plus the square root of 25 is 5 square roots of 2. Can I combine these together? Well, again, do we have like radicands? No, we do not. The square root of 5 and the square root of 2 are not the same, so there's nothing else we can do. It is in simplest form. Let's look at B. The square root of 2x times the quantity, the square root of 6x minus 11. So the square root of 2x times the square root of 6x is the square root of 2 times 6 is 12. X times x is x squared. The square root of 2x times negative 11. Remember, just smush them together. When you have a regular number and a radical, all you can do is smush them together. They're not like terms. So I have negative 11 times the square root of 2x. Now there's nothing I can do with this term over here, but with the square root of 12x squared, I can simplify that. So 12 would be 4 times 3 times, and then I'll take the square root of x squared, minus 11 square roots of 2x. So I have the square root of 4 is 2, and the square root of x squared is x, So I have 2x square root of 3. 3 has to stay under the radical, minus 11 square root of 2x. So is there anything else I can do? I can't simplify 2. I can't take the square root of 2. I can't take the square root of x. So since these radicands are not like, I cannot add them, and I am finished with B. All right, let's look at one last example for 3. Again, distribute the square root of 5a times the square root of 5a. Now this is a special one. You may remember the rule, you may not. So I'll just go ahead and work it, and then we'll talk about the rule when we're finished. The square root of 5a times the square root of 5a is the square root of 5 times 5 is 25. A times a is a squared. Plus the square root of 5a times 3, remember just smush them together, 3 square roots of 5a. And that equals, what's the square root of 25a squared? Well, 25 is a perfect square. The square root of 25 is 5, and the square root of a squared is a. So there's nothing left under the radical, plus 3 square roots of 5a. Now you might look at this and think, oh, 5a is 5a. I can combine like terms. But 5a is not the same as the square root of 5a. This is actually a much smaller number. These are not like terms, so there's nothing else you can do, and our answer is finished. So hopefully you remember that when you multiply two radicals together, like the square root of 5a times the square root of 5a, it pops out of the radical. We talked about this in the last lesson, things like the square root of 3 times the square root of 3. That's the square root of 9, which is simply 3. So if you can remember that rule, you can skip this step altogether. You could have skipped this step right here and just written 5a, like the square root of 3 times the square root of 3 is simply 3. Anytime you multiply two like radicals together, it always pops your term out of the radical. All right, I think this is where we'll stop with this first video, and maybe we can even finish this lesson in the second video.